Now we're going to look at a specific type of equilibrium, solubility equilibrium. It has to do with when you have a solid that is at equilibrium with its dissolved ions. Remember at the beginning of the semester we said that some salts dissolve in water and some don't? There's really some gray area there. In other words, those things that we said didn't dissolve in water, and they appear not to, because if you put them in water, there's a crystal that just sits there and won't dissolve. There's probably some that are dissolving. Some of the ions are leaving and being dissolved, but then they occasionally come back to the crystal or recrystallize. So it's just that in those we said weren't soluble, the concentrations of the ones that were dissolved are very, very, very small. Okay. So this is an equilibrium, opposing reactions. So here's the reaction, and this is general. This is C for cation, A for anion. And remember to dissolve, an ionic compound breaks into its ions. So solid here, AQ there, show the charges on our ions when they break apart. We can do a equilibrium constant. When we had the Kc, the C was just for concentration. I think I told you that I like to just call it an equilibrium constant like this. I don't write that a whole lot, but I say equilibrium constant because it's kind of general. It could be a Kc. In this type, and you know, we're going to see, there's also a Ka, and I'm trying to think of what else we have. Anyway, this one's KSP. So when we go to set up this KSP, we're going to have our products on top. And we would normally have our reactant here. But there's a problem because notice that our reactant is a solid. And if you'll remember, in equilibrium constants, we do not include solids. So I'm going to get rid of that. And it's understood to be a 1 there. And so this is all we have for our equilibrium constant expression for this kind of equilibrium. It doesn't have a denominator. Okay. And now you can see why we call it a solubility product. It's a product as in we're multiplying things together. So this number, the KSP, is going to be a product of the ions concentrations. Let's look at a specific compound and come up with the expression for its solubility product. So this is lead iodide, and we need to be able to figure out these charges because when it breaks apart, so there it is as a solid. Over here I need to have it broken up, and AQ, aqueous, with the charges shown. And then I also need to pay attention to that too. That means I'll have 2 of these iodides. Okay, so there's my equation, my solubility equation. And then so to get my KSP, I'm going to take my products and then remember I use this 2 to give me a 2 here. Here are some examples like equilibrium constants. You can look these up, and actually these are very common to look up because you can tell the solubility of a salt based on its KSP, its solubility product. Notice that these numbers are really, really small, and that means that these are not very soluble at all. In fact, these are compounds that we would have considered insoluble at the beginning of the class. So, does KSP vary with temperature? Yes. Why? Well, all equilibrium constants vary with temperature, but the reason why is that energy is a product or reactant And so then we use Le Chatelier's principle to decide which way equilibrium shifts. And definitely equilibrium constants do change with temperature. So they do. And then another thing is a smaller KSP. Does it mean that the salt is more or less soluble? Well, all you have to do is think about the solubility product is the product of the two concentrations. So if this number is really low, it's going to give you a really low KSP, like minus to the minus 39th. So the smaller this number is, the lower these concentrations are, which means it's less soluble. Okay, molar solubility. How much salt can dissolve? Well, the whole point of solubility products and this you know, having an equilibrium reaction, if this solution is not saturated, holding the maximum that it can, then there is no equilibrium. If it's not saturated, then everything will just dissolve. So anyway, solubility is the concentration of a saturated solution where we have the equilibrium. So when we do these calculations, we will be needing the equation, the balanced chemical equation. We'll need to be able to write the expression, and then we'll use the molarity of the saturated solution, and that is basically our equilibrium concentration.